Hello everyone, in this video I'm going to discuss the example for parametric differentiation. So given we have the situation x which is equals to t squared over 1 plus t. Then we have y which is equals to t over 1 plus t. Our parametric equation where t is greater than 0, find the dy dx. So meaning that we have to focus on the x, differentiate the x with respect to t. So notice that we are going to make use of the quotient rule. Let's say this is the u and this is the v. Differentiate the situation, we have dx dt equals to v. Then we have to differentiate the u where we have 2t minus, copy the u, then we have differentiate the v where we have 1. Then over 1 plus t bracket square. Kindly expand the situation where we have 2t plus 2t squared minus t squared over 1 plus t bracket square. Finally, dx dt is equals to dx dt where we have 2t plus t squared over 1 plus t bracket square. So that is the dx dt. Next, focus on the dy dt. So here we have u, here we have v. Again, dy dt equals to 1 plus t bracket, differentiate the u where we have 1 minus, focus on t, differentiate the 1 plus t and we also have 1 over 1 plus t bracket square. Kindly simplify the situation. So we have 1 over 1 plus t bracket square. So here we have dy dt. In order to find the dy dx, the formula will be dy dt multiplied with dt dx, where we have to flip this part. So dy dx is equals to 1 over 1 plus t bracket square multiplied with, we have 1 plus t bracket square over 2t plus t square. Kindly simplify the situation. So the dy dx is equals to 1 over 2t plus t square. Continue with the situation. Determine the value of t when the first derivative is equals to 1 over 3. So kindly substitute the situation. So here we will have 1 over 3 which is equals to 1 over 2t plus t squared. Kindly cross multiply the situation. T squared plus 2t is equals to 3. T squared plus 2t minus 3 equals to 0. Kindly factorize the situation. T plus with the 3. T minus 1. So t is equals to negative 3, t is equals to 1. So kindly refers to the main question. They mentions that t must be greater than 0. Since we have the restriction, so t equals to 1 would be the suitable answer, or we can say valid. For the part 3, shows that we have the value for the second derivative and the value obtained in b is negative 16 over 27. So as we all know, t will be equals to 1. So let's begin. The second derivative is equals to d dt for the dy dx multiply with, we have the dt dx. So kindly focus on the first derivative. Let's say we're going to differentiate the dy dx, which is, this is the u and this is the v. So we have 2t plus t squared. So my purpose is to make use of the quotient rule. Differentiate the 1 and we will have 0. Minus, we have the 1, and then differentiate the v where we have 2t plus t squared. So here we have 2 plus 2t over, we have 2t plus t squared bracket square. Multiply with the dt dx, so it means that we have to flip this part. So 1 plus t bracket square over 2t plus t squared. Focus on the front part. Here we have the situation 0. Continue. If we expand, we will have negative 2 bracket 1 plus t multiply with 1 plus t bracket square over, we have 2t plus t squared bracket square multiply with 2t plus t squared. So that is the second derivative. Continue. The second derivative would be negative 2 bracket 1 plus t bracket cube over 2t plus t squared bracket cube. When the t is equals to 1, kindly substitute. The value for the second derivative would be, if we substitute in this part, 1 plus t, and we will have negative 2, and then we have it over. If we substitute 1, so we will have 3 to the power 3, which is 27. So finally, the second derivative is equals to negative 16 over 27, and we can say we already show the situation. Thank you so much for watching this video. If you think the video is useful, kindly consider to like, comment, share and subscribe.